Alright folks, Mr. Barry here one last time for this Nearpod, and we're talking about taking information from an absolute value function or an absolute value equation, and what we're going to do from it is pull all the information out and be able to draw ourselves a graph. We have some common information we've been referring to this whole time. You can see the general form for an absolute value function, as well as the fact that we know that h comma k is our vertex, and we definitely need to also check out a. A is the slope to the right of the axis of symmetry. For this problem right here, I have this function, which again should look slightly different than the first two for a couple of reasons in this situation. And we'll go ahead and, as always, when it comes to absolute value functions, we're going to check out and try to figure out if there's anything we could figure out about the vertex first. The h, as we've been mentioning, is usually the one where people trip up the most. I'm looking inside of the absolute value. Here it's x minus 2. And trying to figure out what the letter h is, and I want to know what value for x would make the inside of the absolute value 0. I have x minus 2 is equal to 0. I'll do the inverse operation, and I get x is equal to 2. So if I took the number 2 and I plugged it in for x, there would be 2 minus 2. That would be 0 inside the absolute value. That's how I got x is equal to 2 down here. And since I got x is equal to 2, that also means for us when it comes to the vertex that h is equal to 2 as well. That's half the vertex. The other half of the vertex comes from the letter k, which we know usually is on the back end behind the absolute value, not attached to it, but separated by either a plus or a minus sign. If I take a look over here at the absolute value we have for this problem, there's nothing. There's nothing at all behind it. There's nothing there. Now, we could, hypothetically, if you needed to, since this is an adding and subtracting situation usually, we could put a plus 0 or a minus 0 on the back end to keep the identity the same. If we add 0, if we subtract 0, that doesn't change anything. Or we could just think of it as the fact that then there's nothing there, that k would be equal to 0. So I have my h value is 2, my k value is 0, there's nothing behind the absolute value here. So I know that my vertex would be the point 2 comma 0. Again, one of the ones that kind of trip us up when we graph them, we need to think to ourselves, where would we be at for 2 comma 0? I always start at the origin when trying to figure out a point. And 2 means I go to the right twice. There we are. And then 0 means that I don't go up and I don't go down. So I'm staying right here on our x-axis at the point 2, 0. That right there would be our vertex. Finally, I need to figure out what's going on with the letter a here. A is usually that coefficient in front of the absolute value. We know it's the slope to the right of the axis of symmetry. And here, in this problem, it's 1/3 that's negative. So since it's negative 1/3, and we've been talking about positive means we're going to go upwards first for slope, negative means we're going to go downwards first for slope, but we're always going to head to the right first. So if I had to write out, and you don't have to do this, but it might be helpful just for helping you out. If I had to, that means that I'm going to go down 1 and to the right 3. Again, that slope of negative 1/3, or a value being negative 1/3, means to the right of the axis of symmetry, we would have a slope of negative 1/3. Kind of give myself a visual. Again, let me go ahead and draw the axis of symmetry in here. Axis of symmetry is whatever that x, or in this case h value is. So our axis of symmetry is going right through the spot in the whole line there. X is equal to 2. It's imaginary. And I'm going to go from that spot down 1 and to the right 3. So let's go down 1 and to the right 3, down 1 and to the right 3, down 1 and to the right 3. I'll go ahead and try my best to connect the dots here and remind you that the same exact thing is happening on the opposite side of that mirror. We're going to use negative 1/3, but instead of negative 1/3, it's going to be positive 1/3. Or I could just think about using the mirror here. So for instance, this dot right here is 3 spots away from the axis of symmetry. We could put one 3 spots away on the other side. This one is 6 spots away. We can go 6 spots away over here. This one is 9 spots away from the axis of symmetry. I can do the same exact thing here. And I'll just finish it out like that. And if I connect those dots, my black marker, make sure to draw our arrows on the end, I would have our absolute value right here. By the way, just to double check myself, traveling from left to right, how we read, I go up 1 and to the right 3, so the slope here is positive 1/3 compared to over here where the slope would be negative 1/3. Go ahead, just for the heck of it, you might as well erase the axis of symmetry. You don't need that in there. That's definitely help you graph it. But we should be able to see here an awfully wide absolute value function. Y is equal to negative 1/3. Absolute value of x minus 2.